All right, so I am back and I've got, what I'm going to do is I'm going to measure A595 of the fractions that I've already collected, those fractions number 1 through 5. So the first thing that I'm going to do is put 900 microliters of my Bradford reagent into a visible light spectrum cuvette and go about and blank all my cuvettes. I'm reading my spectrophotometers, I'm reading one wavelength at 595 nanometers, not subtracting the background, read blank. So I'm going to do this for all 4 of the spectrophotometers so I can get kind of a baseline for all of these different instruments. So I can use that to, evaluate my fractions that have come off my column and say whether or not there's protein. I have blanked all my cuvette or spectrophotometers. I'm taking 100 microliters of my first fraction, which is the fraction that I really don't expect to have a lot of protein, if any protein in there at all. And I'm going to show y'all. Well, I do see a little bit of a hue change, so I do expect there to be some absorbance in the sample. So that does indicate that there is some protein. So reading my first sample, spectrophotometer number 10, negative 0.060. Okay, so that is number 1, negative 0.060. Okay, I'm going to go ahead and get the other one. So a somewhat surprising development was the very first sample gave me negative values for all the spectrophotometers, but they were all fairly close together. Negative 0.060, negative 0.031, negative 0.039, negative 0.032. So that to me is like an early indication that potentially, these numbers are legit and the instruments are, I guess, better able to read within the visible light spectrum than in the UV spectrum, or at the very least at 280 nanometers. So at any rate, I'm going to go ahead and do the other samples and arrive at some kind of conclusion with respect to all of these data points. All right, so the data that I've collected from these first 5 samples and our 4 spectrophotometers, what I did was I took 900 microliters of Bradford reagent and 100 microliters of each of the fractions that I collected. I added that 100 microliters to the 900 microliters after I had already blanked my spectrophotometer with that 900 microliters of the Bradford reagent. I blank every single time. So what I will do is I will add 900 microliters to my cuvette that has at the bottom a label of C. There's a letter C and 2. That letter C to me is an indication that I'm using a visible light cuvette. So I'm going to add 900 microliters to this visible light spectrum cuvette. I'll put this into the spectrophotometer. I will press read blank. Once that has completed, I will then add my 100 microliters of my protein fraction to that 900 microliters. Pipette up and down to mix it thoroughly, put it back into the spectrophotometer, and press read sample. Okay, so I want you to follow that same process every single time. I've done these 5 samples, and what is interesting and a contrast from the A280 measurements. What's interesting is that spectrophotometers 1, 10, 9, and 5, they all have results that are fairly consistent and fairly comparable to one another. So if you look at my data sheet right here, which I can't really see, so it's kind of tough, but I looked at sample 1, 2, 3, I skipped 4 and 5, because I wanted to see, this is sample number 3, this is sample number 4. They both, to the naked eye, are comparable in terms of what they look like. So they both kind of have a reddishness to them. At any rate, sample number 1, I got those negative values that I previously mentioned. Sample number 2, I got 0.224 or 0.244, 0.204, 0.223, 0.227. Those are all within 10% of one another. Sample number 3, the one that I very obviously have something in, my presumption is that something is protein. I got absorbances of 1.059, 1.055, 1.070, and 1.074. Sample number 5, like I said, I skipped 4 to look at sample number 5, I got 0.721, 0.764, 0.777, 0.769. Those are within probably 5% of one another. That to me shows that initial spike or that peak where I see a high level of absorbance and then the absorbance drop off. So a high amount of protein elutes from the column with no additional sodium chloride containing buffer. It goes up and then it comes down. I would expect in sample number 6 and probably number 7, I would expect number 6 to be comparable to number 2, where I have an absorbance of approximately 0.2. I would expect number 7 to be 0.1 or something like that. So over the course of the first 7 or so samples, I would expect most of the protein that did not adhere to my column to be flushed out. Now, the next thing that I'm going to do is I'm going to let the next 10 fractions flow through, and then I'm going to use my sodium chloride containing buffer so that I can elute proteins that are currently adhering to that column. I'm going to refresh or I'm going to revisit this in just a little while. All right, thanks. All right, so now I've collected a total of 15 fractions. Fractions number 14 and 15 gave me absorbances of negative 0.009 and negative 0.012 respectively. That's what I'm talking about when I'm looking for something that's consistently low. So those are very close to one another and they're effectively 0. So that's my indication that I have no protein. Okay, so that's 15 fractions. If you look at my setup right now, well, my buffer is all the way to my top line. What I want to do is I want to transition away from using my wash buffer to using my elution buffer. And so what I'm going to do is hold what will be my 16th fraction, which I believe will not have any protein in it because, well, I haven't changed my buffer at all. So fractions 14 and 15 are going to be similar to fraction number 16. What my real goal is to get this solution down to that second black line or the lower black line. Because then whenever I add my elution buffer, well then that elution buffer is not going to be diluted at all. Okay, so it looks like I might take more than one or more than a 16th fraction, but instead I've got to basically just get this buffer as low as I possibly can. And, you know, for the sake of organization, what I'm going to do is I'm going to say this 17th fraction. Well, my 17th fraction is just going to be the result of my wash buffer and none of my elution buffer. So what I'm going to do is mosey on down to get my elution buffer, which I have in another beaker, and I'm going to carefully add the elution buffer, which has my 0.25 molar sodium chloride. Add that. Okay, so now fraction number 18. Fraction number 18 should begin to have the results or kind of the influence of my sodium chloride in that solution. So I will collect. And again, I'm collecting approximately 1 milliliter. So I've got it marked off. And I'm watching up here. And seen. Okay, so this sample right here, if I were to put money on this, do I expect there to be protein in here? Well, if there is, it's a very, very low concentration. The reason for that is my elution buffer has a sodium chloride concentration of 0.25 molar. Well, the solution that is in, that has made it through my stationary phase of my column, well, that's actually a mixture of the wash and the elution buffer. So it's going to take a little bit of time, and it's going to take a little bit of more of that solution to flow through for me to feel, or for my column to basically really show the impact of that 0.25 molar lysis buffer. Or sorry, elution buffer. So I'm going to get some more of it. I'm going to add more of it to my column. I'm doing this oh so carefully so that I don't disrupt the resin, and I'm going to collect 5 fractions. One, 2, and this, I guess this would be like the third milliliter basically to come off of my column. This is where I'm beginning to think that maybe, just maybe, I'm getting some of the proteins that were adhering to the column. They're beginning to feel the impact of that sodium chloride within that dilution buffer. Okay, so it's continuing to go. Looks like I'll be able to get 2 fractions out of this. Yeah, that's what I'm going to do. I'm going to get basically 2 fractions. I'm going to put the cap on the bottom of my chromatography column once it hits that black line right here that my index finger on my right hand is pointing to, and see. Okay, so now I've collected several fractions that have the results, or the proteins from, proteins that were adhering to the column. So I'm going to go ahead and check the absorbance at A595 of those. Okay, so I've measured the absorbance of fractions number 18 and number 19, and here I'm about to do number 20. So I blanked here, and now I hope this is dramatic, and I hope this. Okay, so without a like completely white background, it might be a little bit tough to see, but that did definitely get more blue, so that's an indication that proteins are eluting. So the awesome thing about this is that that is an indication that there were proteins that were adhering to the column. And then whenever I changed my buffer, lo and behold, proteins came off of that column. So fraction number 20 here gives me an absorbance of 0.071. So what I see is, or what I saw is fraction number 18 with a negative 0.013. Now, does that make sense? Okay, let's think back. So fraction number 15 was the last one that I collected. And then I said, now what I'm going to do is just collect everything that flows through my column. So fraction number 16 and 17 are the result of basically getting the rest of that wash/lysis buffer out of my column. Fraction number 18 was whenever I have added my elution buffer. So think about that elution buffer, and it doesn't necessarily have a pigment or anything like that, but just imagine whenever you add it up here, well, sure, it's going to diffuse through, but is it going to, do you think, diffuse all the way to the bottom of the column like that? I wouldn't expect it to. So it's going to be a gradual process. So essentially, my elution buffer is added. It's largely going to stay at the top half of the column. So fraction number 18, getting a negative number where there's effectively no protein in there kind of makes sense. Number 19, I see an absorbance of 0.120. Okay, that's a spike in protein. So that's my first peak that indicates that I do indeed have protein that is eluting off of that column. Fraction number 20 is 0.071. Now, what do I expect to happen over the next few fractions? Do I expect that it's going to go up to 0.120, 0.1 or 0.071, and then flatline? It may not. What all matters, what is all very important, is you need to have, or you need to provide enough of that sodium chloride so that proteins that need 0.25 molar sodium chloride will elute from that column. So the earliest proteins that elute from the column, they're going to require a little bit less sodium chloride than the last ones that elute from the column. Okay, I'm going to go ahead and collect 2 more fractions, and then I'll be back. Okay, so what I've decided to do is jump ahead. I have a total of 20, let's see, 6, 12, 18, 22. So I'm going to measure the absorbance of my 22nd fraction. I'm going to read my blank. Okay, now I'm going to read my sample. Now, I'm using this against the, oh, it became a little bit more blue. It definitely changed its pigment. Now I'm going to read my sample, 0.011. Okay, so I skipped 21, 0.011. What I'm seeing is that fraction number 22 has some protein, but it's not a lot of protein. Now, Will everyone's chromatography results be the exact same? Not at all. Why? Well, first and foremost, this is a technique that everyone is doing. Well, you've done column chromatography, you do that in organic labs, but it's to avoid disrupting the bed resin is no trivial task. That's something that everyone kind of like, you bump your column, you don't really care about it. As a result, what happens? Well, stuff that was adhering to it either gets delayed in its solution or expedited in its solution. So do I expect everyone's chromatography results to be the same? I do not. Now, as a result, I think that the best thing for everyone to do is to collect 15 fractions with using the lysis buffer. Then, at that point, transition to the elution buffer. Transition to the elution buffer and collect 15 fractions. Now, you might be thinking, why 15? That seems like a lot. Well, one, the flow rate of these columns is pretty good. These columns are in good order, and I'm not just saying that because I poured them, but they are fresh. They don't have a bunch of junk clogging them up, which is kind of a problem with older columns. Point of that is it won't take a long time to collect those 15 fractions. So collect 15 fractions, switch buffers, collect 15 more fractions. Do not discard your column, but instead at that point, do your A280 measurements and your A595 measurements. After that point, you can then transition to doing your A340, your LDH assays. I recommend doing that just so then you can get a good idea that, yes, everything that does not adhere to the column has flowed through. Those first 15 fractions where you're washing the column, the resin here is probably 3.5 milliliters. So if you wash this column with 15 milliliters, that's nearly 4 times the volume of that bed. So that's a good volume to wash this column. So lots of the stuff that does not adhere to the column is going to flow through. Now, your elution buffer. Well, your elution buffer is a little bit tricky because what you will likely see is, right, this is, I think, where most people are going to experience the greatest variability. Some people will have the first 3 fractions, every protein dilutes off there. If you disrupt your resin or your bead bed, well, then that's going to throw off when proteins dilute from the column. So that's something to be careful and considerate about. I collected 22 fractions. I expect in fraction number 23, there would be some more protein in there, maybe not a lot. But again, I don't know exactly if every protein, like whenever I collect the next 8 fractions to get me to a grand total of 15 with the elution buffer, I would expect that there's going to be a peak for the proteins that just need a little bit of NaCl. Then it's going to drop, and then there's going to be another peak, and then it's going to be low, and then it's going to peak, and then it's going to probably stabilize. And what I'm talking about is these peaks. I'm talking about my A595 values. I expect to go up, down, up, down, up, down, and stay down. All right. Well, I hope this is helpful, and go get them.